For question number 27, part A, we have to evaluate the definite integral. And because it's a definite integral, so let's try to use the property which says that if the limits are 0 to a and the function is f of x into dx, it can be written as 0 to a f of a minus x into dx. So using this property, our integral, let's say this is I, it becomes integration 0 to, this is pi by 4. 0 to pi by 4 is a minus x. Right. And this is x is now pi by 4 minus x divided by, this is 1 plus cos of 2 into x is, this is pi by 4 minus x plus sine of 2 into pi by 4 x. Okay, so finally I is equal to, which is 0 to pi by 4. And this is pi by 4. And let's say this be equation 1. Let's say this is I. So I is equal to this, and this is now pi by 4 minus x to 1 plus. So cos 2 into pi by 4, this becomes cos pi by 2 minus 2x plus, this is sine of pi by 2 is 2x. Okay, now I is equal to 0 to pi by 4. This is pi by 4 minus x upon 1 plus. Now 90 means change, so this is in the first quadrant, so this is sine of 2x plus this becomes cos of 2x. Let this be equation 2, so let's add 1 and 2, so 1 plus 2 gives I plus I is 2i. 2i is equal to limit 0 to pi by 4, and this is the first equation, so x plus pi by 4 minus x upon, this is now 1 plus cos 2x plus sine of 2x, because this is same, so it remains as it is into dx. So this is dx. This gets cancelled, and finally we have 2i is equal to pi is out. This is 0 to pi by 4. Now this 1 plus cos 2x. We all know that cos 2x is equal to 2 cos square x minus 1, which becomes 1 plus cos 2x is equal to 2 cos square x. So instead of 1 plus cos 2x, we can write 2 cos square x plus sine 2x. Now sine 2x is equal to 2 sine x into cos x. So this becomes 2 sine x into cos 2x. Okay, so I is equal to pi by 8, and this is 0 to pi by 4. Let's take 2 common in this, so this is 2 is common. So finally this is 1 upon cos square x plus sine x into cos x into dx, and this is now I is equal to pi by 16, 0 to pi by 4. Now let's divide each, the numerator and the denominator, by cos square x. So this is 1 by cos square x, and this becomes 1. And if we divide this with cos square x, okay. So finally this is now equal to I is equal to pi by 16, 0 to pi by 4, 1 by cos square x. is secant square x upon 1 plus, now sine by cos is tan x, and this is dx. I is equal to pi by 16. Now, let's make the substitution here to solve this. Let's say 1 plus tan x is equal to t, and differentiating this with respect to t gives us, so differentiating this with respect to t, we get, now the differentiation of tan is secant square x into dx by dt, which becomes dx is equal to dt. So this has to be replaced by dt, and this becomes t. And let's get our new limits as well. So for this, when x is equal to 0, t becomes, so when x is equal to 0, tan 0 is 0 and t is 1. And when x is equal to pi by 4, so t becomes, so tan pi by 4 is 1, so t becomes 2. And finally, our new limits are I is equal to 0, 1 to 2. Secant square x into dx is dt. This is t, which is 1 to t log. So differentiation of this is log t 1 to 2. So I is now equal to, this was pi by 16 was r. So this is pi by 16, pi by 16, pi by 16 into log 2 minus log 1. So I is equal to, we know the log 1 is 0. So this is pi by 16 to log. So pi by 16 into log 2 is the definite integral of question number 27.